Hey, I'm Vintrox. I'm a pink lad here at Form, and I do basically all of the software development for any of the custom software we use. So you might have seen my work in the Form shop for our merchandise. You might have seen my work in the telephone application if you were a participant in that event. And you might have seen my work in this event that you're watching right now or at FormFest back in June. As you might have noticed, these events are using custom technology. We're not using a commercial streaming service that a lot of events like these would use, something like Twitch, because it isn't really the best tool for our unique circumstances. So this presentation is going to be a little different than the one I worked on with Noah for the same event about music publishing, because here I'm going to be focusing on how the technology behind these events, behind FormFair and FormFest works, why we made the choices we did, and how I built all of this to handle our unique use case. So I guess the main thing that you might be wondering is why wouldn't we use an existing service? Like basically a lot of events that I see right now either chose to go with a Discord call, you get in a Discord voice chat and you play everything through there, or you stream it on Twitch. Now there are advantages to these, sure. It's a lot easier to set up if you don't have the skills to do something different than that, and it's very mass market, so it's intended for large numbers of users to be able to work with easily. But there are a lot of downsides to it because all of these technologies are fundamentally streaming technologies. And these events that we organized, everything is pre recorded. We get all of this days at least in advance. So it doesn't really need to be streamed. And there are downsides to streaming that are completely avoidable in cases where you're not really streaming things. When you're actually doing streaming, these are necessary. So of course you have to deal with them. But when you're not streaming, why would you deal with all the complexity of streaming that leads to things like, for one, people getting behind and ahead of the stream, and so you have inconsistency where someone might be a minute behind the stream because of network connectivity. And there's more complexity in hosting too. You need someone with a reliable upstream internet connection that's fast enough to handle the stream and who is consistently available to manage everything, which leads to administrative overhead. And the reason that a lot of these things were unnecessary for our use case and that we chose to avoid them is that fundamentally we didn't need streaming. All of this video already existed, so why not put it in a form where your computer can get it ahead of time, and all your computer needs to do in order to stream it is to make sure that you're watching the video at the right position. It's essentially the same kind of technology that you would use for something like synchronized YouTube viewing, where you've got a stream of content that already exists, and the only requirement is making sure everyone's at the same position. So that's basically what I built for these events. So with this technology, what do we get? We get avoiding having to have someone running the whole thing. You set it all up in advance, and it's good to go. There is nothing you have to do. Not even on the day of the event. You don't have to press play because it's all pre-set up to automatically start at the exact time the event starts, and everything just runs automatically because the computers can handle it. There's also very low back-end web server load because pretty much everything is actually handled by the front end in the architecture that I set up, which is what we're going to get to soon. And you have adaptive bitrate streaming, so slower clients with not enough network capacity to download the full 1080p stream can just stream in a lower quality. And you've got perfect set scheduling, so everyone's at the same point. You don't have issues with people being significantly off from the stream. It's automatically corrected, so everyone's within about 10 seconds of each other. And you have perfect timing too, so you don't get off schedule because the schedule can be perfectly calculated, which is how we have exact to-the-minute set times built into the site. So how does the actual video technology behind this site work? Well, we use a technology called HLS, which stands for HTTP Live Streaming. It's a technology that was designed by Apple for adaptive bitrate streaming, meaning you can switch between different streams depending on what bitrate your device and network is capable of handling, and also potentially what technologies you're able to stream. In the case of FormFair and FormFest, we use the same codecs for all of these. So for audio, we're using AAC, and for video, we're using H.264, which is not the best video codec ever in terms of compression rates, but it's very compatible with pretty much every end-user device, and it's reasonably fast to encode, which is important because I don't have an incredibly powerful computer to encode all of these videos on. So I have a script that's set up, and what the script does is the script takes in a single video file, and it creates the HLS streams for 6 different qualities. So one of these is audio only. You'll get that one only if you click the audio only button when you join the stream. And the 5 others are 240p video, 360p video, 480p video, 720p, and 1080p. Now each of these is also associated with an audio bitrate in AAC, so lower qualities also have lower quality audio to ensure that there is a lower overall bitrate and to decrease the bitrate of the video and the audio both. And so the way that this HLS works is that it splits all of the videos, each of these streams, each of these 6 streams is created, into small segments. So you can choose the length of these segments. I went with 4 seconds. So each of these segments is about 4 seconds of video. So it's a little tiny file that contains 4 seconds of H.264 and AAC encoded audio and video. And then there are big lists created, big manifest files that are in an M3U8 format. So they're an M3U playlist, kind of the same that you would use to play a playlist on your computer in like VLC or something, except that these playlists have lists of tiny segment files that it can switch between. So the manifest file, which is what HLS uses to do adaptive bitrate streaming, contains the list of all of the hundreds of little 4-second segments that make up the video, and there's a big manifest file for the entire video that contains links to the different individual manifest files for the different bit rates, and also notes what the bitrate of those files is. So the client, the HLS client, which is a JavaScript library that's a hls.js, which I use on the client side to perform the HLS encoding, will figure out which stream to use based on your client bitrate, and it'll find the newest segment and it'll download the segments one at a time, and it can prefetch. It can go up to a few minutes ahead, so you've got all that video fetched already. If you have high enough bandwidth, then you can start prefetching 1080p video. If you're lower, you might start prefetching 480p video. But either way, the prefetching is what allows more consistency than you would get with something like Twitch, because with Twitch, you can't prefetch the video because it's being live streamed from the live streamer's computer. In this case, all the video is already there, so it can download it ahead of time and just use HLS to make sure that you're getting an acceptable quality that fits your network connection. And that's why I transcode everything into 5 different video qualities plus audio only ahead of time. Now, once all these hundreds of individual segment files for each quality created, which adds up to thousands of files per video, if a video is up to 30 minutes long, say like they were for FormFest, then all of those individual segment files and the big M3U manifest files that contain links to all of those individual video files are uploaded to a server somewhere that is able to deliver all of those. Now, what I chose for this is an object storage service, which essentially just lets you upload large numbers of files to deliver them to people. And the one I went with is StackPath's object storage service. Why did I go with it? A few reasons. One of them, it's really fast. They're actually just white labeling a different storage service that's compatible with Amazon's, which is the biggest in the world for this, called S3, Simple Storage Service. But the service that they're using is called Wasabi. And Wasabi is less expensive, but has some concerns that I really don't like and couldn't use for this for a few reasons. One of them is their policies, if you read the fine print, say that you can't download more than you're storing in a month. And obviously, these files are being delivered to a large number of people. I'm going to be using a lot of transmit bandwidth. And the other one is that you have to pay for a minimum of 1 terabyte of storage with Wasabi, which is $6 a month or so. With StackPath, I have to pay a minimum 50 cents a month, and they charge me 1 cent per gigabyte per month for storage and nothing for transfer, which is great because I'm transferring a whole lot of data. And if I was storing this on something like S3, where transfer bandwidth is expensive, then it would get really expensive really fast to be delivering all of this large amount of video. So that's what I went with for delivering it. So the front end of the site itself, the actual client that's responsible for handling all of this, just has to handle, essentially, figuring out what set should be currently playing, where in that set it should be, and then loading in the correct video file and telling HLS.js, the JavaScript client I use to play HLS files, this is where in the video we should be, now play it as a giant file in the background of the site. So the way that works is there's a big JSON file. Now JSON is JavaScript object notation. It's the way that you essentially write an object in JavaScript, but it's also a general way of transferring data through the internet. So JSON is a common file format for anything that is supposed to be computer readable, but it's also fairly human readable, so you can look at it and understand what's going on fairly easily compared to some representation formats. So what the JSON file does is it has a few things in it. One of them is the start time of the event, so that's when the timer should go from the event is counting down to happening in an hour to the event is happening now. So that's when the event actually starts, represented as a big long date string. And then it has a list of sets. For each of those sets, it has the name of the artist, it has the duration of that set in seconds, and it has the URL of the big video playlist that's stored on StackPath's object storage server. So the JSON file is used by the front end to figure out what set is currently playing and where in it should be. So this is some fairly simple date math. What it essentially does is it finds the current date, finds the difference between that and the start date of the event. If you're before the start of the event, it'll show the countdown. If you're after the start of the event, it'll figure out what set you're currently in, or if you're after the event, by basically just adding the number of seconds of each set in a row onto the start date of the event and seeing whether that's before or at your current time. So if the first set is 900 seconds long, then it'll take the start date of the event, add 900 seconds onto it, and then see if the new date that it gets is before or after the current date. And what you want to find is which set you're currently in the middle of. So you keep doing this until you find a date that when the duration of the set is added onto it would be after the current date, but is currently before the current date. And that means that your current date is between the start of that set and the end of that set. So then what that does is it means that the difference between the start date of that set, which you got by adding on the number of seconds of each set repeatedly, and the current date is how many seconds you should be into that set. So it'll get the video file from that set out of the JSON file, load it in, and then set the current time to the number of seconds. And it'll also run it repeatedly on a loop in case you get off by too much. If you're too far off from where you should be, change the current time or recalculate what set you're in if it's a different set. So this means that since all the data that's necessary to run the front end for actually playing the video is in that one JSON file that's essentially part of the front end, all it has to do is load it. There's no server necessary to do any of this. All you've got to do is deliver a bunch of files, and then everything else is run client side, which eases a lot of workload and essentially makes everything basically infinitely scalable as far as actually delivering the video and playing the sets goes. So there's a lot of reduction in capacity required there versus a more complex service like a streaming service, because everything relating to how the sets are played, when the set should be played, is all calculated front end. Now, another thing that's important to note is that it's possible that the client-side clock is off. So when the site first loads, it'll ask a different server, what is the current time, and that server will deliver the exact current time, and then it will figure out the difference between the client clock and the exact remote clock, and then just store that difference to compensate for any changes in dates. So instead of having to get the date from that server every time, it gets it once and then figures out how much your clock is offset. If your clock is 20 seconds fast, then it'll just make sure that it compensates for that difference in your client clock every time. Now, there's also the little box that tells you what all of the exact set times to the minute are. That works essentially the same way. It just takes the start time, adds on the number of seconds of each set, which is hard-coded into the JSON file, and figures out what the time would be, and it just repeats that on loop through all of the sets, figures out what the times are, and then puts them into the front end. Very simple, and it's perfectly reliable because all of those sets will be played at that exact time because it knows exactly how long they are, and the client will always play them at the right time. So there are a few other components of the site too. There's the art gallery, and the art gallery basically just, again, that's in the JSON file. There's a list of all of the links that the username should go to, the text for the usernames of the users who made that art, and the link to the image file for that image. So then it uses some code and the CSS grid layout to lay all of those images out in a grid in such a way that they're in columns, so they're, depending on how big your screen is, maybe 3 or 4 columns of images, and all of the images are stacked up in such a way that you don't have like a bunch of white space below each row of images if the images are different resolutions. The code that handles that layout isn't the best, but it works. Now, there's one other thing related to actually playing the videos that's made my life a bit difficult, and that's browser autoplay policies. Basically, browsers have decided they don't like people autoplaying video with sound. So that's why when you go to the site, you have to click the Join Event button to actually start playing it, and that's also why there's some warnings if you're on Safari or on a mobile device, because Safari and mobile devices are more strict about these autoplay rules. Sometimes things will work anyway. I don't know exactly what all the autoplay rules are because it varies a lot depending on your device and your browser, but there's a warning there just in case things go wrong. So there's an alternate mobile site. The mobile site, what it uses is an audio-only stream, and this is actually a stream, like a live stream. It's delivered using a technology called Icecast. Now, what I'm just doing for that is I'm Icecast streaming from my computer the audio from the site to an Icecast server, and that Icecast server then just delivers that audio using a stream that is a constant stream. It's not a bunch of different individual video streams for each video, it's just a live stream that keeps going throughout the entire event with the audio. Now, this is actually the same technology that OpenPit uses for their events, although they use a company called Mixlr that hosts their Icecast servers rather than doing it themselves, because it's hard to scale Icecast at times, but we don't have enough users on the mobile site that that's enough of a difficulty. So that's how I got it working on mobile in cases where the autoplay rules don't allow things to work properly. The last pieces of the technology to note here are the donation counter and the viewer count. Now, these are the only parts that actually involve any sort of server. Everything else here basically just involves delivering files and client-side calculations. These parts require a server. So the way that the viewer count works is every 5 seconds, your client sends a ping to that server. Now, that ping contains a uniquely generated local ID, and it contains your IP address because that's just sent as part of the request every time, no matter what. You can't do anything about that because it needs to be able to route that back to your computer. So the IP address is a unique address for your internet connection, and the unique ID is just something that's generated from random data client side. So the server prevents you from having more than 3 active clients from any IP address at the same time. So we don't have someone who opens up 10 different windows like happened during FormFest, messing up the viewer count statistics too much. So every 5 seconds, what it does is it sends that ping, the server stores it in the database, and what the server does is it looks in its database, and it gets the number of pings from unique user IDs, that's the randomly generated user ID that the client sends, over the last 10 seconds. So if there have been 80 users that have sent a ping, at least one ping, there could have been 2, over the last 10 seconds, then it'll send back, okay, there are 80 currently active users, and that's what displays the viewer count on the site. Now, the issue with this is that sometimes you get a lot of pings because every client is sending one every 5 seconds. So during FormFest, we had millions of pings get stored in the database. So this makes things really slow because I'm running this on a cheap server. So what I have to do to make that keep working is to clear out the database to take all the old pings, say older than a few minutes old, and move them into a separate table that doesn't get looked up until I want to do statistics or analysis on this of some sort. And then only the recent pings are stored in the table that's actually looked up to figure out what the recent ones are. And that makes sure that the response times for this don't get really bad and everything doesn't get really slow. And that was happening during FormFest, but luckily it only affected the things that were server bound, so that's donations and the viewer count. There are definitely better ways to set up viewer counting than this, but this was a simple strategy and it's the one I went with, and it worked well enough, so I'm keeping it for this event as well. Donations work kind of similarly. There's an internal administrative panel that we use to add donations, and the server just stores a big list of donations, and the donation total is the sum of all of those. So every 5 seconds, when it sends the ping, it also gets back what is the current donation total. And this is also what we use internally for the FormFest raffle, is we had a shuffle component in this that would figure out, based on the number of raffle entries people had, one every $5. It would just generate a big list of raffle entries, and it would randomly select a number out of that, and it would take that and say, this is the winner. So that's how we handle donations. That's pretty much all of the technology that handles the site for FormFair and FormFest. If you've got any more questions about how this worked, feel free to reach out to me in the development channel in the server, or just send me a message. I'm happy to help anyone who has questions about this. It's a cool technology, and it's helped us to solve a lot of the issues that come up when you're using traditional live streaming technology for a circumstance that doesn't really require it. I'm also working on a new platform based around these ideas to help virtual events that are more scalable, more reliable, and less difficult be available to anyone. This is currently still kind of early stage. I'm working on it hard though, and Aaron and I are working on this project together, and we're hoping to be able to announce something with that within the next few months maybe. So look out for more on that. Always working on new technology to help people hosting virtual events to do that better. Thank you for coming. I'll probably be putting this up on YouTube later for anyone who missed it, but thanks for being here.